you're thinking? You're thinking, wait, Mrs. Ford. The sine of 15, I know how to do that. You made me do it on the quiz. In fact, you made me do a harder one than that on the quiz. How could we do the sine of 15? 60 minus 45 would definitely be an option. It's not the only option, is it? But it's a fine option. And what's our formula say for the sine of 60 minus 45? Let's do it without our purple sheets now. We need to know this. What's that say? Sine 60? Cosine 45? Minus, because the signs stay the same in sine formulas. Sine 45. Sine 45. Cosine 60. And then we'll plug in our numbers, right? And hopefully we know the 45s are root 2 over 2. I know that because I practice all the time. Hopefully you've been doing something so you know that too. 60s, I get them mixed up, so I always have to draw 60. So the sine is root 3 over 2, and the cosine is a half. So the sine of 15 is root 6 minus root 2 over 4. Now that is not new. That's review, right, for all of you? But anybody who has a book open, read the directions. This is the new part. What do the directions tell you to do? Find the sine of 15 using the half angle identities. Now we hadn't talked about those yet, so we're going to talk a little bit about them today. The half angle identities, and they're on your purple sheet so you can see. The one we would use for this problem, because it's a sine problem, is this. There it is. There's the one we would use for this problem because it's a sine problem. Now, we're finding the sine of 15. So right here, this is 15, which means x has to be what? X is not 15. X has to be 30. We're finding the sine of 15, which is the sine of 30 over 2. These formulas, the half angle formulas, are the only ones that require you to make a decision about whether you're going to use a positive or a negative. They're the only ones with square roots. All the rest of them work out perfectly the way they're supposed to. Here you have to make a conscious choice. Keep in mind, we are finding the sine of 15. In which quadrant is 15? First. What do you know about everything in quadrant 1? It's positive. So we're going to take the positive square root. X was 30, so we'll put that in here, and there it is. There's the setup for the problem. Our problem is finding the sine of a first quadrant angle, 15 degrees. We know that's going to be positive, so we choose the positive root. 15 is half of 30. Now, if I'm walking down the street and somebody says, find the sine of 15, I can do it either way. But this problem said specifically, use the half angle identity. So, what do you think I'm going to do next? I have my formula all set up. What do you think I'm going to do next?
Plug in the cosine.
I'm going to figure out what the cosine of 30 is, and I'm going to plug it in. What's the cosine of 30? Root 3 over 2. So I have 1 minus root 3 over 2. Now, do not break out into hives. It is perfectly okay to have radicals under radicals. It's not, like, beautiful or anything, but it happens. That is a mess. How would you suggest we clean that up? We've done this before. Multiply everything by 2. So if I multiply everything by 2, that's everything, I'm going to have 2 minus root 3 over 4. Now, when you take the square root of a fraction, how do you do that? How do you take the square root of a fraction? Square root at the top over square root at the bottom? Now the square root of the top is just going to stay that ugly mess. But how about the square root of the bottom? Isn't that nice? I don't have to rationalize or anything. It came out all by itself. This is the answer. Now, you might be thinking, wait a minute, Mrs. Ford, you told me this was the answer. Let's type these into our calculator and see if they're the same decimal. So type that in and type this in, and let's see if we get the same decimal. Remember, as always, you got to close. When you hit the radical sign, you get these parentheses. Make sure you close them. Hit equals after you get in your numerator. Hit equals before you hit divided by, so that you are doing the entire numerator. I got 0.2588 for this one. Tell me if that's what you got. Oh my goodness gracious, I got 0.2588 for this one. And now just for kicks, I'm going to press sign 15 on my calculator. And sure enough. So we got two very different looking answers, but they do indeed give me the sign of 15. Okay? Let's try one more. Let's look at number 33. It says find the cosine of 75. Let's use our half angle identities to find the cosine of 75. This is your half angle identity. That radical is over the whole thing. Now, if we're going to use the half angle identity to do the cosine of 75, what are we going to have to let x be? Remember, this has to be 75 here, so x is going to have to be what?
150.
150. So we're going to think of 75 as half of 150. So then our formula will say 1 plus cosine 150 over 2. Before we go any further, let's take care of this plus or minus. We don't want to have that confusing us down the road. What's this problem asking me to find? Cosine of 75. Where is 75? Which quadrant?
First quadrant.
First quadrant. What do I know about
Always
everything in
positive.
first quadrant?
Always
Positive.
positive.
So we're just going to forget the plus or minus. We know we're going to get a positive answer. What do I need to do next? I need to find the cosine of 150, which has a reference angle of 30. Now be very careful. You still can't lose sight of these negatives. What's the cosine of 150? Negative root 3 over 2. Uh-oh, this is starting to look familiar. What do I do now? Multiply by 2. These are going to cancel, that's why you did it. And then what's our last step? Take the square root, the top, you're stuck with it. The top just stays just like that. But the bottom, the square root of 4 is 2, so you don't have to worry about having a radical in the bottom. Anybody have an issue with that? Okay. The next thing I'd like you to do, thank you, is get out your packet. And if you look, there is, on the second page of the packet, it says in class 21312, and there are a couple of equations there. It's got a cartoon. Oh my. I forgot I put that cartoon on there. That cartoon's a little questionable. It's kind of racy. It's a racy math cartoon. Take a look at it and see if you can figure out why it's racy.
What is racy?
Mother is sine squared.
That's not one.
Kid is 1. Dad is tan squared. But mailman is cosine squared. Okay. Little racy math. Okay.
Do you get this? Do you not get it?
Cosine squared, sine squared equals 1, and this is tangent.
All right, let's see if we can solve these equations. This is a necessary
That
skill.
is correct.
Here we go. Take a look, directions say 0 to 2 pi. Now it's written in interval notation this time. We haven't seen that in a while. But that means everything from 0 to 2 pi. So we're going all the way around the circle, but we're going to answer in radians. Okay, who's got an idea? Look at the equation. It looks like it's ready to go, doesn't it?
Jen, what's it called? The, I don't know what that thing's called. Foil.
Okay, factor, which is like the opposite of foiling, but yeah, we want to unfoil it. We want to factor it. This is a quadratic. I don't know how to explain that to you. That needs to pop out at you. You've got a squared, something squared, the same thing not squared, and a constant. This is a quadratic equation. So how would it factor? What would I have to put in the front of my parentheses? I need a 2 sine squared, so I'm going to have to put a 2 sine and a sine. Multiplying would give me 2 sine squared, right? Now I need a 2 on the end. There's only one way to get a 2. You're going to have to multiply 1 times 2. Now, I don't know where to put the 1 or the 2. I can switch them if I need to. But the idea is when I do this multiplication, outside, inside, it adds up to 3. Do you see a possibility here?
Yeah.
This, if I put a plus here, would give me 4. And if I put a minus here, would give me minus 1. So there's the 3 that I needed. All right, what happens next? I got the right factoring now. So what happens next? Set them both equal to 0. Oh. I want to talk about this one for a minute, because I don't know that this has happened to us yet. This says sine equals -2. I want you to think about that for a minute. I want you to think about having an angle with a negative sign that's 2. That would mean opposite over hypotenuse is 2 over 1. Is that possible? That triangle should make you, like, quiver. No, you can't have that, because doesn't the hypotenuse have to be the longest? Okay, this isn't possible. Remember your sine curves, boys and girls. Regular sine curves go up how far? 1. Down how far? -1, period. You don't have sine values outside of that range. That's it. This is not possible. It's extraneous, no solutions. Now, what about this one? Can the sine be 1/2? Yes. It would be 1/2 in quadrant 1 or 2. Agreed? Sine is y is positive in 1 and 2. So if the sine is 1/2, that's perfectly legit. Emma Veely. So root 3. How big's this reference angle right here?
30.
30. But I'm in radians. So 30 is what fraction of 180?
Pi over 6.
Pi over 6. So what are my answers to the problem? One of them would actually be pi over 6. This is the other one. How big is that angle?
That angle is 150.
It'd be 150. It'd be pi minus pi over 6,
Yeah.
which is 5 pi over 6. So your answers are pi over 6 and 5 pi over 6. Anybody have a question about that problem? Something about that problem you're not sure
How
about?
do you know you're in radians?
Directions.
Oh, okay, to the right. Gotcha.
Now, the next one, I know I'm in degrees. And if you look at it, because the next one says, solve between 0 and 360. So that's your clue, you're in degrees.
Super good.
Is that about the same kind of problems we had here? Can you see that? So you know how you're going to start, right? You're going to start by unfoiling it. Deanna? You feeling okay? All right, let's get focused on the math, okay? Now, okay, so what am I going to put in the front?
Tan squared.
I gotta multiply and get 2 tan
Oh,
squared,
tan.
so I'm gonna need a 2 tan and a tan. Remember, I'm foiling to get this term. Now I need to put a 3 and a 1 to end up with a 5. Now be careful, it's gotta be a 3 and a 1 positive and 1 negative, so I think that's the combination that's going to work. Because what does this give me when I FOIL?
Negative
What does
6.
this give me?
Positive
What
1.
do I get when I add those together?
Negative 5.
Does it matter what order you put the 1 in the negative 3?
If you don't put them the way I have them, you won't get the right middle term.
Okay.
If you put the 1 here and the 3 here, your middle term does not come out to be 5, negative 5. Now, if you put a 1 here, or let's say minus minus. If you did that, your middle term would come out to be negative 5, but your last term would be wrong. There's only one way to factor this. And the whole idea is take the time to FOIL it out and see if you got the right one. Okay, we're gonna need a calculator on this one because this says the tangent equals negative 1/2 and the tangent equals 3. And I don't know either one of those angles, so I'm gonna need a calculator. Where could the tangent be negative?
3.
No, not 3, 2 and 4. How do we know the tangent's negative in 2 and 4?
Because it's 1 positive, 1
Because 1 positive and 1 negative sign is y over x. So I'm going to type it on my calculator, make sure I'm in degrees. And then how do I get an angle on my calculator? What will I actually type? Second tangent. And I always just put in the positive, because what I really want to know is this angle right here, and it's about 26.6. 26.6 is not an answer to the question, though, is it? What's an answer to the question? Right here. What is that? 153.4? How'd I get 153.4? 180 minus 26.6? And then the other answer's all the way around here. What's that one going to be? $333.4. And how'd I get that one? 360 minus. You can't answer negative 26.6 with these directions because those directions say I gotta be between 0 and 360, and that's not. If I didn't have those directions, that would be perfectly fine because that is that angle. Where's the tangent positive? I would need a positive 3 now. That would be in quadrant 1 and 3. So I'll type in my calculator, second tangent 3. And I get 71.6. So what are the answers to that part of the problem? 71.6 is one of them. Yes, you're right. And what's the other one going to be? 251.6. And how did you get 251.6? 180 plus 71.6. Let's turn it over. All of this should be pretty comfortable for you, except maybe the first problem. We're not going to get this done. We're almost out of time, believe it or not. But let's at least get it started so we can pick up here tomorrow. How do we begin this problem? It's an equation, just like the two we just did. But they were ready to solve. This one isn't. What's wrong with it? Well, it's got to get equal to 0. Okay, I can do that. But there's still something wrong with it.
It's not the same.
This guy is problematic. We talked about this on Friday. What do I need to do? This is not good to have in the same problem with this. So what can I do with this?
You can do the multiple.
I have a formula for it, right?
Yeah, you can do
In fact, I
cosine
have
squared.
3 of them. So looking at the problem, since I have a choice, what might be the smartest one to replace it with? 1 minus 2 sine squared? Because you have a sine in the problem. If this had been a cosine, I would have used 2 cosine squared minus 1. What next? Yeah, let's combine like terms, clean it up a little bit. I got a 1 and a negative 2, so I'll add those together. I've got this personal issue with this negative, so I'm going to divide it out. You do not have to do that. Does it look now like the other ones looked? How does it factor? You need a 2 sine squared, so you need a 2 sine and a sine. Now wait, that's a plus 1 on the end, so doesn't that mean both signs have to be negative? And it's a 1. There aren't any choices. It's got to be 1 times 1. Do outsides and insides. Does that give you what you want?
Yeah.
So we're ready to go. What does that say? Sine equals 1/2. I'm setting those equal to 0. Or sine equals 1. What about sine equals 1? That's a little special. What do I have to look at there? The unit circle, right? I got to go around the circle. Your homework for tonight, please pay attention so that you do the right thing. It's the last sheet in your, next to last sheet in your packet. It's called, no it's not, wait a minute. It is the last sheet in your packet. The last sheet, it's called Review Sheet 5.1 to 5.4. That's your homework. Review Sheet 5.1 to 5.4.
Right.
It's kind of long. Spend at least 45 minutes on it. Hope you didn't do anything last night. Scoundrels. You turned me off.
Steven, can you read?
Stir,
Thank you.